Good evening. In this video, I would like to make a brief introduction about the elements. And the video will contain three parts: history, contents, and some of my own thoughts and understandings while reading this book. So, approximately 2,300 years ago, the ancient Greek mathematician Euclid wrote this book, The Elements. But it not only contained Euclid's works, it also collected some other earlier mathematicians' works, such as Hippocrates, Eudoxus, as well as Theaetetus. And some people might think this book, The Elements, are talking about plane geometry only, but it is partially correct. We can see that in the first 6 books, it focused on plane geometry, but it actually has another 2 topics. From book 7 to book 10, it discussed number theory, basically focusing on the arithmetic of natural numbers. And from book 11 to book 13, it discussed solid geometry, which expanded the scope from a 2D plane to a 3D Euclidean space. And the components of this book, the elements, can be divided into 4 different types, which are over 100 definitions, 5 postulates, 5 common notions, as well as over 400 propositions. So the first time I read this book was about 20 years ago when I was in middle school studying plane geometry or Euclidean geometry. Reading this book gave me 2 beautiful insights. The first one is that I understood how logically strict the deductive reasoning can be. For example, we have a proposition, 6, let's assume, and if we have a look at the proof process, it can be divided into many different steps. For step 1, step 2, step 3, until step 5. And we concluded that this proposition is true. So every step must have a very clear reason. And the reason can be a definition, a postulate, a common notion, or a previously proved proposition. So this is the reason. It's pretty clear and strict. It can never be something like summarization or observation or something even imagination. Never. This will never happen. So we will see how strict the deductive reasoning is. Besides, I think if we take a close look at every step, we'll find that there is absolutely no mind gap. No gap between every step, so the complete process is pretty tight, and I think they are continuous. And the second insight is that this book gave me a systematic perspective to geometry. For example, if we have proposition, let's say 17, and in order to prove it, we have to use, for example, definition 8 and common notion 3, as well as propositions 6 and 10. This is just an example. Numbers is very likely to be inaccurate. So rather than seeing this as a proof process or proof chain, we can have another perspective. Let's say we can see them as a relationship of dependency. Proposition 17 depends on definition 8, common notion 3, and proposition 6 and 10. With these thoughts, we can actually build a very huge and complex network of dependency relationship of all these all these components. For example, component 1 depends on component 2, and component let's say 5 depends on component 2 and component 1, and probably component 4. Things like we can build a very big network about the dependency relationship. This helped me understood how each component is related to each other. So I can see the geometry as a system, and each component is a node in the system, and they have a very strict relationship to each other. So this is my second insight. And it is absolutely different from my middle school textbook, which just randomly mixing some geometry concepts like putting a circle, a triangle, a line segment together without knowing how they are related to each other. So with this perspective, I think it is pretty interesting to review geometry, review what I have learned. It's really interesting and I believe useful. And I think that is the end of this video. And in the next video, I'm going to introduce another important concept in the elements, which is called straight edge and compass construction, also known as Euclidean construction. So thank you for watching. Have a good day.